So the first part I'm going to start with on this project is the carriage stop body. Right, I like to, when I make a project like this, I like to start out with a main component. That way when I make other pieces, I'll have something to hang them on, and I can watch the thing sort of come together as I make the parts. So let's look over the drawing a little bit. It's always good to familiarize yourself with the drawing before you start cutting metal, because once you start cutting metal, if there's something you don't understand on the drawing or something you overlook, then you're liable to scrap the part out. So let's look over this thing a little bit. First thing I want to look at are the outer dimensions. Okay, we have a 1.625 on the width, 2 inches on the length. Thickness is 1 inch plus 15 thousandths. I must have been in some kind of a foul mood when I designed this thing, and I added this little feature out here. It looks great. It'll look good when it's done, but it's kind of a pain in the butt to machine, but that's the way it goes. So 1 5/8 by 2 by inch and 15 thousandths thick. And usually if I'm doing an aluminum part or something like that, I'll usually throw an 1/8 inch extra on each side or on each dimension for stock, just because it's easy to machine. Steel, it takes a little more time to machine, so I'll probably cut it down to a 1/16 of an inch. So we're going to look for a piece of stock here, inch and 11/16 by 2 1/16 by inch and a 1/16 or so. The stock I found on my shelf is 1 1/4 thick. I'm going to use that for the thickness. Okay, so the first thing I'm going to do is I'm going to saw out the piece of stock. Okay. Then I'm going to go in the milling machine. I'm going to square that piece of stock up down to this 1.625 by 2 by inch and 15 thousandths. Let's see, what next? Probably, while it's still in block form like that, I like to go through and put all the holes in, because it's easy to hold on to, and it's easy to locate holes off a square block surface than it is after you start cutting radii on it and notches out or cuts out of it, and get it away from a block shape. So what do we have to do? We have a couple 0.33 diameter holes to put in here. We have an 1/8 inch reamed hole through here, +1 minus nothing for a dowel pin. We have an 832 tap here to hold the dowel pin in. This was a change I made on this. So you notice that we're at Rev C on this now. Originally I had that a press fit in there, so it's kind of a one-time assembly. You drive that pin in to the threaded shaft, and once it's in there, it's not coming out. So I changed that, and I made the pin floating, and I put a set screw in to make it easy to disassemble if you want to. Okay, what else do we have? We have a 7/16 hole through here for the sliding pin. It's 7/16 plus 1/1000th minus nothing, so we have a clearance on that pin. What else do we have to do? We have to do this silly indicator pad here. Okay, like I said, that's kind of a pain in the butt machine, and I'll probably put it on a rotary table and cut this radius on the rotary table, and while it's in that same setup, I'll go and work on the other side. I'll just lay the thing out with some layout die and just mill to the lines. It's not it's not critical. It's just aesthetic. So there's no reason to make it perfect. What else do we have? We got to cut this notch out of here. Okay, that's a little end mill job. Got to cut these steps over here where the thing sets on the ways. Again, this is designed for an Atlas lathe. It'll work on other lathes too. The only thing you have to do is redesign this area here a little bit. If you have a lathe with V ways on it, you'll have to allow for that over here, so you have some stock to cut the V in and figure out how it sets on your ways. But it'll still work the same. It'll fit most any small lathe. It's pretty small. This is a pretty small carriage stop, so it's not going to fit a large lathe. That's not to say you couldn't redesign the thing and just blow it up bigger if you wanted, but this one's designed for the Atlas, and that's kind of what I'm going to stick with here. So let's lay this thing out and saw out the stock. Okay, nothing too magic about this. I don't know what this steel is. I just pulled it off the shelf. It's probably mild steel. We'll find out when we start machining it. Okay, about 2 1/16 long and about 1 11/16 wide. Again, we're only leaving a 1/16 of an inch on, so be a little careful when you lay it out and saw it so you don't run out of stock when you're squaring it up. So let's move on over to the bandsaw and saw this out. Alright, I have my bandsaw set for about 100 surface feet per minute for steel. I have a blade in here with a 1/2 inch blade with 5 teeth per inch. Should be pretty good for this thick piece of steel. So let's go ahead and saw it out. This is going to take a while, so I'm not going to bore you to death with an endless camera shot. We'll just start sawing here. I like to use a piece of wood, push on. It's a lot more comfortable because this is going to take some time. It's not doing too bad. It's working its way through. Put some wax or oil. Let me grab a little cutting oil to throw on there. Maybe that'll speed it up some. That's a little better. That's good. Blade came off, so now I can stop, put that back on. I'm not going to bore you with any more band sawing. Finish sawing this out and we'll move on to the next step. So I was able to get through the rest of this thing without throwing a blade again. This bandsaw has always been a problem in that respect. It's kind of light, and I don't think you can get enough tension on it to keep the blade from slipping. As soon as it slips on the tire, it walks off. Someday maybe I'll be able to get a real bandsaw, but until then, keep playing with this one. I did realign the tracking on the wheels lately, and that helped. But still, as soon as if I try to push it too hard and it slips, it pops off. It's something to get used to with the various machines we use. Alright, this is done. Okay. So now we'll move over to the milling machine and square this baby up. So now we have the block all sawed out. Now we need to mill the 6 sides square with each other and to size. I recommended that you watch my squaring video on this topic, so this will be kind of like a review. First thing, I know there are a few out there that don't like to hear this, but I always stress safety. I'm going to be working with rotating machinery now, so the first thing I do is put safety glasses on. Second thing, I get rid of the long sleeves. I know it sounds trivial, but I've seen a lot of really bad stuff in my career. This machine is fully capable of removing my arm, and I don't really want to experience that, so I'm going to get rid of my long sleeve shirt before I even turn the machine on. So, enough said about that. Let's move on. Let's put a fly cutter in. Get this thing squared up. First thing I want to do, I'm going to pick the largest surface on the part. It's one of these two, and we got a fairly square surface here. I'll put that against the solid jaw. This is a sawed surface over here, so I'll use a piece of wire. I like to use wire on this side just to even out any high spots on the sawed surface. Okay, tighten it down. And this is the first surface. I want to take off as little as possible. I don't want to go overboard on my first cut because I don't want to run out of stock on the other side. This is this is about what size is this? Let's see here. About a 2-inch cutter. 4 times. You should know my RPM and cutting speed video. Formula for RPM is 4 times the cutting speed divided by the diameter. We have steel here. It's about 100 surface feet per minute. 4 times that's 400 divided by 2. It's about 200. I like to go a little faster with a fly cutter because there's only one cutting edge and it can handle it without heating up. So I'll run this about 300 or so. Somewhere right about there. Okay. We'll just run down till I scratch the surface. I like to climb mill with a fly cutter because it leaves a nice clean edge around the part. See the cutter's coming around and it's hitting the edge of the part from this side so it doesn't raise a burr on it. Steel's making a pretty good cut. I don't know what it is. It has a little bit of carbon in it. Head looks pretty good, like it's pretty well trimmed in. Now we're coming back the other side and climb milling on the back side, so it doesn't leave a burr there. Looks like it's trimmed well front to back. We're just scratching the surface here on our previous cut. That's about done. Now we have a flat surface to work off of for the squaring up the rest of the part. Let's put that freshly machined surface against the solid jaw. And we'll do the next one of the next larger sizes or sides. You know what, I'm going to get a little shorter. Some parallels are a little shorter here so I can have more of the machined edge on the back jaw. Something like that. Okay, we don't have to worry about hammering anything down yet because we don't have a finished surface down against the parallels. Finished surface in back, so I'm going to climb mill on that surface so I don't raise a burr. This saves me filing time. Again, we don't want to take off any more than absolutely necessary, just enough to clean it up. Didn't quite make it, so let me go back and take a little more off. Another 10,000ths ought to do it. Those hot steel chips just ricocheted right off the center of my lens on my safety glasses, so I'm glad I had them on. Okay, so now we have our first machine side and our second machine side is square to it. Let me grab a file. and take the burr off of this side. Now we have two machined edges adjacent to each other, so that's a finish. Those are two finished surfaces. We can go ahead and take the burr off. All right, now I'm going to flip it over, flip it 180, put my surface I just machined down. And we'll go ahead and take a cleanup cut on this. Now we have a machined surface down, so we need to hammer it down on the parallels. I like to use a ball peen. I take all kinds of grief over this, but it's the best hammer for the job. I've used them all, and as long as you're hammering on an unfinished surface, ball peens work great. Just use the edge of the hammer or the ball, and acts just like a dead blow hammer. It's small, so you can get your fingers around the part. When you tap it down, you can feel just when it settles down on the parallel. That parallel is nice and tight. They don't bounce. I mean, a lot of people say, oh, you can't use a ball peen hammer because the part bounces. Well, bull. Here it is right here, nice and solid on the parallel. So let's go ahead and clean this up. I'm going to grab the crank so we can see what we're shooting for. Looks like we're shooting for 1 5/8 inches. Well, since waiting for it to finish, we're going to be remachining this edge in this side anyway. So now we can go ahead and measure this, see where we're at. We've got 1.703. Hammer it back down. Every time you take it out, you got to hammer it back down. Nice and tight on the parallel. Okay, where is my calculator? We got 1.703, and we want to end up at 1.625 minus, we have 78 thousandths to go. So I'm going to set my, you can't see that, let's see. Maybe you can flip it over here. I don't know if you can see that or not. Yeah, I guess you can. Loosen my dial on the knee, and I got 78 to go, so I'm going to set on 0, then move 78 thousandths to the left. 78 right there. So this way, when I crank it up to 0, the part will be to size. Okay. Alright, I'm going to stop maybe 15 thousandths before 0 so I can take a trial cut and just double check my setting. Alright, this is going to be a little healthier cut. We're taking about 65 thousandths or so off. Making some blue chips. Like a medium carbon steel. It's definitely not a low carbon steel. It's got a pretty good finish. It's going to get some nice blue chips. I'd say blue chips are okay on a fly cutter like this because the tool has time to cool down. It doesn't heat up like an end mill. As you don't start getting that light blue color, start to change to the next stage. My car will survive quite a while with this kind of steel. The nice thing about it is, if it gets dull, all you gotta do is sharpen it up again. That's why I don't care for carbide in situations like this. Carbide's not good on an interrupted cut anyway, but even with end mills, once the carbide gets dull, that's it. You're out, you throw it away. Or if it gets chipped or banged, you drop it. All you gotta do is drop a carbide end mill, and you might as well toss it in the trash. It's going to chip. high speed. High speed is a lot more versatile for the home shop. More forgiving, a lot less expensive. Alright, so now let's move up to within 10,000ths of my finished dimension. Take a cut. And I can double check, make sure everything's set right. If I miss set, you guys are still looking at the dial, aren't you? That's great. Let's look back over at the what's going on. I need a camera. Too many things going on at once. Okay, now let's pull this off and measure it. Should be 1.635, right? We're 10,000 short. Okay, it's 1.633. So I got 8 thousandths to go. Put it back in here. Use the soft hammer now because I'm almost down to a finished surface. I don't want to leave dents in it. Just a nylon hammer. Not a dead blow or anything. I don't like them. I don't think they're necessary. Okay, 8 thousandths. Got fine milling on the back side now, so I'll have a little bit of a burr to take off, but it's going to have to be deburred in there. That applies more to roughing cuts than finishing cuts. Okay, let's see where we're at here. Go ahead and knock that burr off. Yeah, it made a little bit of a burr. Alright, this should be 1 5/8. 1.625. Okay, we got that to size. So now we got 3 sides finished on it. Let's go ahead and put my other parallel back in now. Okay, now we don't have to use the wire. Got nicely machined sides to clamp on. Let's go ahead and hammer it down. Both parallels should be nice and tight. They are, because they're part square. Go ahead and take a light cut on this side. Now this fly cutter might reach all the way across this part. Let's see. Yeah, it looks like it will save us an extra cut. I'm going to, while it's taking this trial cut on here, I'm going to set my knee, the dial on my knee to 0. Actually, that's not really necessary because I'm going to change it anyway when I measure it. But let's see here. Alright, let's see. Let's measure this. We're looking for 1 inch and 15 thousandths. We're going to have to hog some metal off this one. Remember, it's 1.25 inches to start, so we got a ways to go. So 1.204. That one doesn't want to go down. This flip it 180 here. There we go. Alright, now we have... Now I forgot what I said. 1.204. 1.204 minus 1.015. We got 189 thousandths to go. So I'm going to set my dial to 89 from 0. We'll go that plus one more turn, that's 189. I think I can probably manage about a third of that at a time. 60 thousandths a cut without too much difficulty. Yeah, that probably moved. Take another trial cut because I hit it kind of hard and I think I may have possibly moved the tool bit. I don't trust it anymore. Better to find out that now than after you get down to your finished cut. I'm grabbing my micrometer and see if that'll fit in there, so I'm going to have to keep pulling it off the parallels. Nope. Alright, I guess we'll pull it off the parallels. .198. $183 thousandths to go. Set my dial. Try not to bump it too hard this time. Actually, we don't need the aluminum anymore. Definitely a higher carbon steel than I thought it was. That's alright. Better surface finish. A little more durable part. If I want to, I can even go ahead and heat treat it. Most of this stock I picked up at an auction. Bought about 3 tons of it. A lot of it's unmarked, so sometimes I don't know what I'm getting, but got it all at a really good price, so it's been paying off for years. I'm going to continue to whittle away at this. No sense boring you guys to tears, so finish this up and I'll start in the next step. we're down to our finished cut. Finish this up and then we'll do the last two sides. Let me go grab a solid square. Tool bit's still hanging in there. Yeah, it left some burrs on at that time from those heavy cuts. On one edge anyway. Alright, now let's go ahead and square this up. Crank the tool away a little bit, it might be easier to hold on to. Okay. Again, only take as much off as we need to clean up on this edge, so we don't run out of stock on the other end. Alright, that's cleaned up. Let's take a finished cut on it, make it pretty. Now with our hot chips. Okay, burrs off of this one. Alright, last surface. This one we'll want to hammer down. Make sure it's sitting on the parallels tight. Get crazy with the first cut, because you don't know for certain how much stock you have here. So never take any more off than you absolutely have to try a cut. Leave a little witness mark on it, you know, leave some extra for the first cut. Just have to machine it enough so you can measure it. Okay, we're at 2 inches 44 thousandths. It's supposed to be 2 inches to finish, so 44 to go. Piece of cake after that last side. 44, set my dial, 44 thousandths. One side is 0, so we end up at 0. Leave about 10 thousandths for the finished cut. See if I can sneak up on it without banging it and messing up the tool. Yeah, the tool's starting to get a little bit dull. Sharpen it up for the next part. check this because I didn't have to take much off. Call it good. Got it screwed up pretty bad and missed the plus or minus 5 thousandths tolerance. Actually, this is more than that. This is a 2-place decimal. This is plus or minus 15 thousandths. I can belt sand that. Okay, so we're all squared up. Get the burrs off. Okay, so there's the first step. Let's go back over to the print and see what's next.